to another installment of addition is all you need. Now, in previous installments, we showed that when it comes to addition and subtraction, addition is associative, and what that means is that whenever addition comes first, I can choose, and I only have addition and subtraction. I can choose to do the second operation first. Subtraction is not associative. And so when subtraction comes first, you have to do the subtraction first. However, I can always replace subtraction by adding the negative version. So I can negate and add, right? And now I've replaced subtraction with addition. So I've replaced this non-associative operation with an associative operation. And that's beneficial, especially when it comes to algebra. So when it comes to the debate between addition and subtraction, well, don't debate. Just remove subtraction as an operation by adding the negative. Now, similarly, for multiplication and division, let's not use 5 here. Right, for multiplication and division, multiplication is associative, whereas division is not associative. Right, and division is not associative. Right, so with multiplication, similar story with addition and subtraction. Multiplication, if it comes first, that can be done first, or you could go to the division that comes next, if you so choose. But when division comes first, like in this case, you would have to do the division first. However, what you can always do is you can replace division by multiplication, but you multiply by the reciprocal, right? So you can replace division with multiplication by the reciprocal. So when it comes to the debate between multiplication and division, well, there's no debate. Just replace division by multiplication by the reciprocal. So instead of dividing, multiply by the reciprocal. Right? So, right, another way this is said is instead of division, you can upturn and multiply. And with subtraction, you can negate and add, right? So now we've replaced subtraction as an operation. We've replaced division as an operation. And now there's no debate between multiplication and addition. Everyone knows that multiplication has a higher precedence than addition. In this video, we're going to show why that is. Why is multiplication? Does multiplication have a higher precedence than addition? Now, so take for instance 5 plus 2 times 3. Now, we're going to start off and we'll deal with just whole numbers. And when it comes to multiplication, what do we mean by multiplication? What is multiplication? Well, this is a short way of writing 5 plus 2 plus 2 plus 2. 2 multiplied by 3 is 2 added to itself. And now, right, this is what I mean. I want 5 plus 2 times 3. That is 5 plus 2 plus 2 plus 2, right? Now I only have addition, right? Addition is all you need. I can replace multiplication with addition. This is 5 plus 2 is 7, plus 2 is 5 plus 2 is 7. I bring down this 2. I also bring down this 2 additions that don't get used and the 2's that don't get used. And 7 plus 2 is 9. I bring down this addition, bring down this 2, and this is 11, right? This is what I mean when I say 5 plus 2 times 3, right? Now, what would happen if I were to do addition first? Right? I don't do an expansion. I just do the addition first. So 5 plus 2 is 7 times 3. And 7 times 3 is 21, right? Now, these are not the same. I'll point out that this is what we mean when I just have the addition, right? So how could we get to the right solution? Well, it turns out the only way to get to the right solution is to do the multiplication first, right? If I want to get this, which is what I mean, well, what I have to do is I have to do the multiplication first. 2 times 3 is 6. 6 plus 5 is 11. As you can see, now we get the right solution, the thing we mean, right? Remember, multiplication is just this short, for the whole numbers, is just the shortening of addition, right? So I know that this is what I mean. So I know this is what I have to get. But how do I get it? I have to do multiplication first. When I do addition first, I don't get the right answer. Now let's investigate what happens here. So I get, 7 times 3, right? I'm just rewriting it this way. And what this means, this is 7 plus 7 plus 7, right? But 7, I can write as 5 plus 2. Right? So I replace, right, each of these 7s with 5 plus 2. Right? Now, addition has another property, right? Addition is commutative, which means I can reorder the numbers, right? So addition being commutative, I'll just do a quick reminder here, says that is the reason why 5 plus 2 is the same as 7. Sorry, that's not, that's actually doing the addition. It's the same as 2 plus 5. Right? That's what it means to be commutative. So I can play this commutative game in such a way that all the 5s show up first and all the 2s show up last. Right? I just commute. Now, what is 5 plus 5 plus 5? That is 3 times 5, or 5 times 3. Multiplication is also commutative. Right? And that's this plus, I bring that down here. And what is 2 plus 2 plus 2? Well, that is 2 times 3. So you see what happens, right? When you do addition first, multiplication has another property. It distributes over addition. So when you do addition first, the multiplication will distribute over the addition. And so you multiply both the 5 and the 2 by the 3 when you do the multiplication first, which is not what we intend to do. We only intended to multiply the 2 by the 3. So in order to prevent the distribution from taking place, you have to do the multiplication first before the addition. Now, if you did intend to do to distribute the multiplication, well, what we can do, or we would do in that case, is put the addition in parentheses. This is to say that I want the addition to be done first so that the 3 gets distributed to the 5. If that is my intention, then the way to do that is put the addition in parentheses. But if I don't want that to happen, I have to do the multiplication first, right? So writing this statement, remember, means this. I don't intend this 3 to multiply the 5. So for that reason, multiplication is given a higher precedence than addition. Right? So we've removed multiplication. Sorry, we removed division as an operation, and we have replaced division with multiplication, and we replaced subtraction with addition. So now the order is MA. In an upcoming video, we will show why exponentiation must have a higher order of precedence than multiplication. Now, similar to how multiplication is repeated addition, recall that exponentiation is repeated multiplication. So perhaps following the way we showed why multiplication must have a higher precedence than addition, you can then show that exponentiation has a higher precedence than multiplication. So go ahead, give that a try.